This circuit can be controlled with simple hand swipe gesture. One direction turns LED on, opposite direction turns it off. In this video I will tell how these reflective photo interrupt sensors work, how to set them up, and how to avoid ambient light's effect on the output. I will also go through the code where gesture detection happens. If you need custom PCBs for your projects, check out this video sponsor PCBway.com. If you need electronics modules, you may find them on their module store section as well. You can order PCBs from them, as well as other parts for your projects, 3D printed parts, CNC machined parts, and much more. For all your prototyping needs, go check out PCBway.com. So this is reflective photo interrupt sensor. There's an infrared LED and phototransistor in one package. Light from the LED can only get to the phototransistor if it is reflected from an object. When LED is turned on by applying a voltage to it through a current limiting resistor, it will emit infrared light. Object in front of the LED will reflect that light and some of it will hit the phototransistor. When infrared light hits the phototransistor, it allows current to flow through it. Brighter the light, higher the current. Object's distance and surface affect how much of the infrared LED's light is reflected to the phototransistor. Current limiting resistor affects the original intensity of the LED. Third thing affecting the output, in addition to the IR LED's brightness and the object in front of it, is the resistor connected to the output side. When phototransistor is connected like this, current flowing through it will also flow through the resistor, and voltage drop over the resistor is proportional to the current. In many cases it's enough to use so high output resistor that the output will act almost like a digital signal, output voltage changing greatly with even the smallest reflected light. To have possibility to adjust threshold distance of these detectors in the software side, I didn't use too large resistor. This allows for variation in reflection to be measured instead of having a flat digital signal. I have connected these LED sections to a GPIO pin instead of powering them constantly from the VCC. This way I can turn the LEDs on, measure outputs from the phototransistor side using the ADC, and then turn the LEDs off and measure again. Difference of those two measurements is caused by the reflected light from infrared LED. Rest is from the ambient. The light originating from the infrared LED is what we use to detect the objects. To detect left or right swipes, I have two interrupt sensors, each connected to their own ADC input pins. Each swipe starts from a state where object isn't detected by the sensor. First sensor to detect the object determines the starting side of the swipe. The last sensor to detect an object before both sensors return to no detection should be different from the starting side of the swipe. Otherwise, the swipe is considered incomplete and discarded. Of course, one could measure time between start of first detection and end of the last detection to check the speed of the swipe, to make fast and slow swipe do different things. Now let's go through the code. First, some usual stuff, like defining some names for the pin numbers, setting output pins, and initializing serial component. Some variables to hold analog measurements, and boolean values of whether sensor is detecting something or not. Here I'm defining an enum called state, which lets me use descriptive names for different states of two detectors, neither, right, left, and both. To detect the swipe gesture I need to handle current state, previous state, and the first activated detector. In the main loop I'm doing what I mentioned before. Turn the LED on and get the output readings using ADC. Do the same with LEDs off and save the difference to the variables. Content of those variables are compared with threshold value to determine whether sensor is detecting an object or not. I selected threshold value by printing the variables values in loop and monitoring those printed values while I moved my hand in front of the detector. Results of the comparisons will give boolean 1 or 0 values for two detectors. I'm combining those into one 2-bit value and saving it as current state. The enum line I showed previously was initialized in such order that this 2-bit value will match the written names of the state. By comparing the current state with the previous one, I can tell if either detector's output was changed. If it was, and neither detector was detecting in the previous state, the first detector to sense an object sets the swipe's starting direction. Then we wait for both detectors to stop detecting again, and if the last detector to the trigger is different from the first, the swipe is complete. If not, it wasn't a proper swipe. If gesture is detected, I can do something based on the direction. Here I'm turning the LED on or off. Things you need to consider when using these photo-interrupt sensors. Select the current limiting sensor on the LED side based on the actual sensor and the output voltage of the microcontroller. Datasheet will tell you the forward voltage and maximum current of the LED. Then select the resistor for the output side. The datasheet probably has the transfer characteristics, but it was easier to try some values in range of, let's say, 1 kilo ohm and 10 kilo ohm. But in the end, gesture controller is working perfectly fine. See you next video. Thanks. Bye.